The largest mega yachts you're about to see in this video are crafted in mega factories, yet only a handful are completed each year. Right now, there are around 3,000 US billionaires worldwide, more than ever before in history. However, only a few hundred of them have enough money to have a luxury mega yacht built, like the one you are seeing right now. So, this is the story behind the construction of the world's largest and most expensive superyachts, built inside gigantic shipyards. So the first phase of building a superyacht is mainly design and engineering. This stage is very important because these yachts are so big, complex, and custom-made. Building them in these shipyards costs anywhere from hundreds of millions to over $1 billion, depending on their size and features. And the production process you are about to see is truly breathtaking. Right now, you're watching the hull of the yacht being welded at the Lürssen shipyard in Germany. There are only about 60 of the world's largest superyachts. Currently, only about 2 to 4 superyachts of this size are built in the world each year. It usually takes 3 to 5 years to build a superyacht, from the first plans to the day it's ready to sail. Besides manual welding, CNC machines are increasingly used for cutting and shaping hull components. Cutting-edge materials and techniques like carbon fiber masts or hybrid propulsion systems are commonly used. Hulls are usually made from aluminum or steel, while superstructures often use lighter composites to improve stability. Only a few superyachts are built each year, making them extremely rare. The world's top shipyards usually produce just a handful annually, ensuring that every yacht receives meticulous attention and exceptional craftsmanship. The scale and complexity of such a build make it one of the most ambitious superyacht projects of recent years. Now, this dry dock is flooded after the assembly of the megayacht Lürssen Blue is complete. This megayacht is over 500 feet long and ranks among the top 5 longest yachts in the world. It can accommodate 48 guests and 32 crew members. The owner of this superyacht is the Vice President of the United Arab Emirates. Its estimated build cost is around $750 million. This specific mega yacht uses a diesel-electric hybrid propulsion system developed in-house by Lürssen. It can run in electric mode for slower speeds and lower emissions, or switch to diesel propulsion when higher speeds are needed. This is how the 300-foot superyacht Norn by Lürssen Yachts touched the water for the first time. The design is bold and unique, with a reverse bow and sharp lines that make it stand out among other superyachts. Every yacht is almost entirely custom-built for the owner. No two superyachts are identical. Interiors can include cinemas, spas, swimming pools, helipads, submarines, or even ice rinks. The superyacht industry is truly global, with shipyards, designers, and suppliers spread across key locations worldwide. Major production hubs include the Netherlands, Italy, France, the United States, and the United Kingdom. More than 2,800 highly skilled employees work at this shipyard dedicated exclusively to the creation of world-class superyachts. This is what the 374-foot Lürssen superyacht Cosmos looks like. It is the first Lürssen yacht equipped with methanol fuel cell technology, allowing near-zero emissions when cruising at slow speeds. The shipyard's production halls are positioned directly alongside a canal with direct access to the sea, making the launch and transport process highly efficient, as you can see right now. One of the most unique features is the owner's private study under a glass dome, connected to a sky terrace with 360-degree views. Building it required specially bent glass. After a superyacht is fully constructed and launched, it usually needs help to leave the dock. Tugboats gently push or pull the yacht to guide it out of the shipyard canal or dry dock. This is important because superyachts are very large and heavy, and maneuvering in tight spaces can be difficult. You are now seeing the production process at Viking and Rasmussen. The shipyard has 5 spacious production halls that can accommodate vessels up to 410 feet in length. Right now, you're seeing the main production hall in Lemferder, Germany. This is the 390-foot-long motor yacht Leva, the largest ever built by a Viking and Rasmussen. Facilities include an inner harbor, a synchrolift, and specialized workshops for processing steel, aluminum, non-magnetic steel, and composite materials. The yacht cost over $300 million, and the owner is billionaire Stephen Orenstein, whose net worth is estimated at around $2 billion. There is a 52-foot-long hatch on the port side for the tender garage, which stores a large dayboat behind it. The black-hulled design features a clean, minimalist silhouette. For instance, the anchor pockets were omitted to preserve uninterrupted lines, replaced with underwater anchors on the keel. An underwater Neptune lounge has a big window that gives unique views below the waterline. The yacht also has a fully certified helicopter landing pad on the sky deck. Since it couldn't yet be launched into the water, it was transported on a special barge. You are now seeing the unfinished superyacht Leva as it leaves the port of Lemferder and is moved to another area of the shipyard. This yacht manufacturer focuses on innovation. They use laser welding methods to create smoother hulls, making them stronger and giving a better finish. This shipyard's production halls are built for high-precision manufacturing and are equipped with gas supply and welding fume extraction systems, dust and gas removal, ground-controlled cranes, and other specialized equipment. They engage in advanced material work, research into lightweight construction, bonding technologies, additive manufacturing, AI-enhanced processes. This allows the owner and guests to arrive directly by helicopter, offering privacy, speed, and convenience. The helipad is on the sky deck, making it easy to reach the top of the yacht. It is fully certified and meets international safety standards for helicopters at sea. I think this superyacht, together with Benetti Luminosity, is one of the most stunning yachts on the oceans. Let me know your thoughts in the comments. The yacht uses a sophisticated diesel-electric system with dual electric motors and multiple Caterpillar generators, providing quiet, low-vibration operation. It has a range of over 7,100 nautical miles at 15 knots. Viking and Rasmussen used laser welding techniques to ensure the hull plating is extraordinarily smooth and precisely finished, helping reduce rework and enhance aesthetics. Their production facilities include workshops for metal fabrication, hull and superstructure construction, assembly, and finishing. This is the Rossinavi Shipyard. It is an Italian shipyard located in Viareggio that builds steel and aluminum superyachts. This is the manufacturing process of Seawolf X. It is a 140-foot-long aluminum catamaran. The shipyard emphasizes that more than half of the craftsmanship in their yachts is done by hand, and all work is done in-house. The hull and superstructure were fabricated at Rosenavi's Viareggio site using aluminium, which allows for a lighter weight and more efficient performance. Onboard artificial intelligence monitors energy usage, guest needs, battery state, and prompts low-impact behavior on board. Welcome to Newport News Shipbuilding, a vast shipyard located off the coast of Virginia. This facility is the only shipyard complex in the United States capable of designing and building nuclear-powered aircraft carriers, some of the most complex machines ever constructed by humans. Depending on its position within the class, building one of these massive warships can take anywhere from 9 to 12 years, from the first steel cut to final delivery. What you are seeing here is the assembly of the forward keel block of the carrier. Unlike traditional shipbuilding methods that progressed from keel to deck, modern aircraft carriers are constructed using enormous prefabricated sections known as superlifts. Each superlift is built separately, fully outfitted with systems and equipment, and then lifted into place with giant cranes. The construction of an aircraft carrier requires a workforce of more than 5,000 skilled shipyard employees, supported by hundreds of subcontractors. It also relies on a nationwide industrial network of over 2,000 companies. The range of expertise involved is vast, including nuclear engineers, metallurgists, electricians, welders, robotic specialists, and naval architects. A single U.S. Navy Ford-class aircraft carrier costs more than $13 billion to build, not including its aircraft. The air wing, consisting of fighter jets, drones, helicopters, and surveillance aircraft, adds an additional $5 to $7 billion. Over the ship's operational lifetime, crew salaries, maintenance, and upgrades push total costs beyond $6 billion. As a result, only a handful of countries in the world can afford to build and operate even one such vessel. A nuclear aircraft carrier serves as a mobile airbase, capable of deploying combat aircraft anywhere in the world without relying on foreign bases. When a carrier strike group arrives off a nation's coast, it instantly alters the strategic calculations of every country in the region. Thanks to nuclear propulsion, U.S. aircraft carriers can operate for more than 20 years without refueling. This unmatched endurance gives them a global operational reach, unlike any other naval platform in existence. The process you are watching is a planned long-term maintenance period for the USS Mount Whitney, a complex refit that lasted nearly 2 years. USS Mount Whitney is a U.S. Navy command ship and the flagship of the U.S. Sixth Fleet, operating throughout the Mediterranean region. Homeported in Italy, the ship was originally built at Newport News Shipbuilding in the 1970s. And serves as one of the most important command and control platforms in the U.S. Navy. This maintenance work was carried out by Genova Industrie Navali, an Italian industrial shipyard group based in Genoa. The group operates several major shipyards, including Mariotti and San Giorgio del Porto, and specializes in the construction, repair, modernization, and life extension of both civilian and military vessels. Over the years, the San Giorgio del Porto shipyard has repeatedly performed major maintenance and upgrade work on the USS Mount Whitney. Planned maintenance of this scale involves far more than routine repairs. Engineers conduct detailed inspections of the hull and propulsion systems, upgrade communication and electronic networks, and refurbish both living spaces and high-security command areas. In total, the USS Mount Whitney spent 148 days in the Genoa shipyard, including 109 days in dry dock, an extensive maintenance period by any standard. At the peak of activity, nearly 200 skilled shipyard workers were on board every day, contributing more than 300,000 man-hours to return the ship to full operational readiness. One of the most demanding tasks was the removal and refurbishment of the ship's massive stern tube shaft. This steel component weighs approximately 33 tons, stretches nearly 50 feet in length, and measures over 22 inches in diameter. The propeller tail shaft, nearly identical in size, was also extracted, carefully realigned, fitted with new coupling bolts, and reinstalled. This type of work requires both heavy lift capability and exceptional mechanical precision. While the ship was high and dry, crews tackled an extensive list of hull and topside tasks. They stripped and repainted everything below the waterline and applied fresh anti-fouling coating to keep marine growth at bay and maintain fuel efficiency. The flight deck, a critical operational surface, underwent comprehensive repair and preservation. Inside the ship, engineering teams overhauled the boilers, refreshed key components of the propulsion support systems, and completed a full service on the emergency diesel generators to ensure reliable backup power. These upgrades, combined with improvements performed in Genoa, helped the Mount Whitney achieve self-sustained electrical and steam capability, meaning the crew no longer needed an external steam barge to supply hotel steam for onboard services. To further enhance resilience, the Navy added an assured power system designed to keep mission-critical electronics online even during power spikes, brownouts, or unexpected failures, essential for a command ship that serves as the nerve center of U.S. naval operations in Europe and Africa. When the 2020 Genoa refit wrapped up, the Mount Whitney sailed back to her home port of Gaeta, Italy, fully restored and ready to resume duties as the 6th Fleet's flagship. After the follow-on regular overhaul in 2022 to 2023, she once again returned to operational status, modernized, strengthened, and prepared to continue her unique mission at the heart of U.S. Navy command and control. U.S. Navy ships operate across every ocean, routinely docking in ports around the world. At the core of this global presence is the aircraft carrier fleet. U.S. Navy currently operates 11 nuclear-powered aircraft carriers and is legally required to maintain this minimum number at all times. Each of these ships is a supercarrier, displacing more than 100,000 tons. No other nation operates nuclear-powered carriers of this size or capability. The Gerald R. Ford class represents the newest generation of U.S. aircraft carriers. At present, only USS Gerald R. Ford is fully operational. USS John F. Kennedy is undergoing construction and testing, while USS Enterprise and USS Doris Miller are also under construction. Building a supercarrier is an enormous undertaking. It requires over 4 million individual parts, around 1,000 separate compartments and rooms, roughly 100,000 tons of steel, and tens of thousands of miles of cables and pipes. In short, a carrier is one of the most complex machines ever built by humans. All U.S. aircraft carriers built since the 1960s use nuclear reactors for power. Nimitz-class carriers are equipped with 2 fourth-generation reactors, while Ford-class carriers use 2 first-generation Bechtel reactors, which are more efficient and produce more electricity. A nuclear-powered carrier can operate for 20 to 25 years without needing to be refueled. Modern aircraft carriers are built using large prefabricated sections. Each section, or module, can weigh several hundred tons and comes with piping, wiring, and equipment already installed. The ship is then assembled like giant Lego blocks, which speeds up construction and improves quality. These modules are so big that some require their own structural analysis before even being lifted into place. Each module's weight is carefully calculated before installation. Even a few tons off can affect the ship's center of gravity, which is critical for flight deck stability. A typical supercarrier is about 1,100 feet long, has a flight deck covering over 4 acres, stands as tall as 20 stories, and carries a crew of more than 4,600 people, including the ship's crew and air wing. Building a Nimitz-class carrier takes about 5 to 7 years, while a Ford-class carrier takes 7 to 10 years because of its advanced technologies and systems. However, planning, engineering, and the manufacturing of components begin years before any steel is even cut. A Nimitz-class carrier cost about $4.5 billion, while a Ford-class carrier costs around $13 billion. Each new Ford-class ship is expected to cost less as construction processes become more efficient. At any given time, 3 to 4 U.S. aircraft carriers are deployed around the world, while the others are undergoing training, maintenance, or overhaul. This fleet enables the U.S. to project air power anywhere in the world within days. Each carrier goes through dry dock maintenance every few years and a major mid-life overhaul called refueling and complex overhaul at around 25 years of service. The refueling and complex overhaul lasts about 4 years and essentially rebuilds the ship from the inside out. There are over 20 different welding processes used on a single carrier. Some welds are tested using X-rays, ultrasonic scanning, and dye penetrance before being approved. Certain critical welds must survive over 150,000 pounds of pressure per square inch in testing. Future crew members move aboard the carrier while construction is still ongoing to learn systems firsthand. They help test plumbing, electrical systems, and elevators before the ship even launches. Each carrier has more than 100,000 compartments, many of which are small crawl spaces under the deck. Engineers and technicians often navigate these spaces in dark, confined conditions, long before the ship ever sails. Even before steel is cut, engineers design spaces for future technology like advanced radars or weapon systems that may not exist yet. Some cable trays and conduits are pre-installed with extra capacity for future upgrades decades later. Every worker on the deck wears a colored helmet system to indicate their trade. There's a person solely responsible for spotting dropped tools because even a small object falling from hundreds of feet can damage expensive systems. Some modules are lifted by cranes that move only a few inches at a time, precisely positioning 100-plus-ton structures. Engineers constantly monitor alignment with laser-guided sensors to ensure everything fits perfectly. Right now, you are watching a special process called dead load testing of the aircraft carrier John F. Kennedy. That means launching large-wheeled orange sleds. Think of them like car-shaped test vehicles that weigh up to 80,000 pounds to simulate the mass of real aircraft. These sleds are launched from the carrier's bow, fly down more than 300 feet of catapult track at speeds over 150 miles per hour, splash into the James River, then are retrieved and reused for repeated tests. Systems like fire suppression, elevators, electrical grids, and even anchor chains are tested on the dry dock or assembly floor. The ship is essentially a floating laboratory before it ever touches the water. Carriers have enough piping and ductwork to fill multiple city blocks. These systems carry everything: water, fuel, air, hydraulic fluid, fire suppression, and even chilled water for electronics. Flight deck paint isn't just non-slip. It's engineered to reflect heat from jet engines and resist damage from munitions and chemicals. Some carriers get over 100,000 gallons of specialized paint applied during construction. A ship built today may host systems 30 to 50 years from now. Every weld, module, and major system is documented by cameras for quality control. These records are kept for decades, allowing engineers to inspect ships virtually during maintenance and overhauls. Aircraft elevators are pre-installed in massive sections and tested in the yard. Each elevator can lift up to 150,000 pounds and must operate perfectly before the flight deck is finished. At peak construction, there can be 10,000 workers from hundreds of trades simultaneously building one ship. The schedule is so tightly choreographed that even a few minutes of delay in one section can ripple across the entire project. This Nimitz-class carrier was launched in July 1990, and it became the first nuclear-powered aircraft carrier named after a U.S. president. Its construction cost was about $3.5 billion in early 1990s dollars. Ingalls Shipbuilding is one of the United States' most important naval shipyards and a major builder of warships for the U.S. Navy and Coast Guard.
You